And welcome, viewers, to the Daily Space Weather, coming at you once again from the Smash News Network. Least busted name in news. We've got no less than 6 likely named sunspot groups. We've got a little bit of solar flaring. We've got a great comet to show you later in the video, so make sure you stay tuned for that. Also, lots of filaments. So that's the last 24 hours from SDO. Let's take a look at all these filaments. We've also got coronal mass ejections to cover and plenty more. So you can see some filamentary activity up there in the northwest, also in the southwest. We've got a coronal hole wind stream currently buffeting Earth's magnetosphere. There is the southeast, and here is the northeast. And thanks for leaving a comment, TinMan1057. Here's the SDO intensitygram. That's yesterday plus today. Again, we've got 6 named sunspot groups. 1, 2, 3, 4, 5, and last but not least, 6. You can see they're all quite far from the equator there as we watch solar cycle 25 continue to ramp up here. And of course, there are a ton of sunspots on the opposite side of the sun at the moment. There's your SDO colorized magnetogram for yesterday plus today. Let's do a volcano rundown. But first, today's featured product is forgive, remember, hold accountable. Because accountability always comes. So why punish yourself by holding a grudge? Holding a grudge, folks, is like consuming poison and expecting the other party to die. So don't do it. Forgive, remember, and hold accountable. Because forgive and forget is so 2019, right? Like I said, accountability always comes. So maybe start a conversation about who needs to be accountable. People have made some bad decisions and destroyed many lives in the past 3 years. If you click the red bubble link below the video, you'll find our products in order of best selling. That's our merch store there. So check it out. You'll even find a re-release of Smasher Price My First Pandemic. We decided to release it because reasons. People like the design. That's the reason. If you want to support the channel, you can do so on Patreon. We are still there. 3 different membership levels available for you there at Patreon. We do need some new equipment to keep these videos coming at you. The best way to support the channel is via a membership at smashomash.com/smashteam. So join at the gold or silver level over there. And if you join at the gold level, we'll even tell you before we release our paper for peer review the mechanism that likely underlies the solar sunspot and solar polar field reversal cycles. It'll blow your mind, and it's going to bring in a new way of considering astrophysics and cosmology, because it's going to put some pieces together in the puzzle of that realm that, well, it'll change all of astrophysics and cosmology. So even geology will beg a rewrite as a result of our paper, so get ready for that. Gold Smash Team members already know about it. Make sure you press login, click posts. You can also find links to the forum, the merch shop, and the homepage at smashomash.com/smashteam. Thanks to our gold and silver Smash Team members, the best value is the gold annual paid-up subscription. It's almost like getting 4 months for free of a gold membership because of the complimentary merch. So, doing the volcano rundown next, we see Etna producing an effusive eruption there. Etna back on the list, producing some new real estate on the Isle of Sicily. Chicarachi continues to explode, producing a 13,000-foot plume of volcanic ash. It's a flight level 130. That is south of Kamchatka, by the way, south of Japan. Also, Mount Aso there, now showing up here on the list. A gas and steam plume rising 300 meters above the crater contained 800 tons of sulfur dioxide emissions. That was way back on the 19th. The volcano is evolving, and an explosive eruption is not ruled out and may occur suddenly. Suwanosejima also erupted, produced a 6,000-foot ash plume. Popocatépetl exploded, flight level 220. It's a 22,000-foot ash plume over central Mexico. Fuego in Guatemala exploding, flight level 190. Sangay in Ecuador exploding, flight level 230. It's a 23,000-foot ash plume. 24,000-foot ash plume from Revenador in that same country. And Cotopaxi producing a 25,000-foot ash plume. Perhaps Ecuador is the best place for a volcanic vacation. Please don't pole vault the caldera. And Sabancaya, not sure if it's erupting. Volcanic ash not identifiable from satellite imagery. Let's move on to earthquakes. There is your 90-day bar graph. Things have been pretty calm here over the past week or so. No major quakes. Let's see what's happened in the past 24 hours. We did see another China quake there. A quake at China quake at 5.3. China quake, probably created in a lab. That 5.3 magnitude quake came in at 17:07 Universal Time yesterday. Also, Malta had a 5.3. We've seen quite a bit of activity there. That 5.3 came in at 1955 yesterday afternoon Universal Time. Yesterday evening Universal Time, I should say. And that's it. Those are the only quakes above a 5 magnitude. Let's get back to space. Here's 335 angstroms, 24 hours of images from SDO. And here's the full disk view in our favorite filament wavelengths, 304 plus 193 angstroms. Shows all the lively activity going on in terms of filamentary behavior. You can see all of these prominences, lots of prominences going on here at the moment, and expect to only see more of those in the coming 2 years because we are nowhere near the solar maximum. So the 10.7 centimeter radial flux now at 136 solar flux units. Let us know in the comments if you think it's going to drop below 130. I don't think it is going to drop below 130 at the moment. But we'll see what happens with these current 6 sunspot groups that we have on the Earth-facing portion of the solar disk. Radial flux 136 solar flux units. There is the Space Weather Enthusiast dashboard. A little bit of geomagnetic unrest here forecasted just before midnight on February 2nd. Not sure what the reasoning is. It doesn't say if it's a CME impact or a coronal hole high-speed stream, but that's NOAA's forecast, geomagnetic unrest late in the day on February 2nd. Planetary K-index is at 3. We do have a high-speed coronal hole wind stream. It's kind of on the weak side. The KP index is a measurement of global geomagnetism. Speaking of geomagnetism, here's Earth's magnetic moment from space out to about 12 Earth diameters for the past 4 hours. And if you want to find out where that comes from, click on the Details tab down there in the lower left. That'll link you to the Space Weather Modeling Framework. You can download all the software from which these models are derived. Here's the last 4 hours of Earth's magnetic moment from the ground level. This will show you the most likely places to see aurorae, pipeline, railway, and power grid induction. Geospace delta B changes to Earth's B field. The B field is the field that goes through the magnet, this magnet being Earth. So there's the past 4 hours. Pretty calm here. And the current situation as far as real-time solar wind. Keep in mind the data here just switched from the ACE back to the Discover. That's this green to blue line. Current conditions are 489 kilometers per second for the solar wind speed. Solar wind density 13.34 protons per cubic centimeter. The Discover is showing a denser solar wind there than the ACE. The rest of that is fairly unremarkable, but this is the signature of a coronal hole high-speed stream right here, folks. If you don't recognize this, let me point it out for you. Right there, you see the velocity rising, and you see the density dropping. So that is a signature of a coronal hole wind stream. Also, the plasma temperature changing here as the high-speed portion shows up. That's sort of what we typically see. And let's take a look at some magnetic data. There your GOES 16 and GOES 18 magnetometers. Fairly smooth here despite a coronal hole wind stream. It's a pretty weak coronal hole high-speed stream in my opinion. And let's take a look at the heliospheric current sheet. So Earth lies in a South Pole-oriented current sheet. No apparent changes coming anytime soon there. There is a little bit of magnetic indecision in the eastern limb of the sun. We'll get a look at that next, right after we show the line of sight field plot. So here's the sun's B field in blue. This line of sight field plot also depicts the solar polar fields in green for north and red for south. And let's move to coronal holes. So you do have a little bit of magnetic indecision happening here. We see north and south pole magnetism up here around the equator for a brief moment. And then it looks like the south pole wins out, as most of the sun's south solar polar field is kind of oriented toward Earth at the moment. So these coronal holes are, except for this one down here, there's one down here, that is North Pole. All of the rest of these are South Pole. So that's the polarity of our coronal holes, and here's the last 24 hours, SDO 211 angstroms. Welcome to the South Pole, the South Heliospheric Pole, that is. We are currently in the South Pole, yes. Next we'll move to sunspots. Again, we've got about 6 named groups here. 3 in the west and 3 in the east. So we've got 2 named groups up here, at least 2 named groups. 1 down here, 2 down here in the southeast, and 1 up here in the northeast. Let's take a look at those from SDO. Here's the continuum plus 171 angstroms. And let's lose the 171 angstroms and zoom in to see any sunspot evolution. So this group up here just spontaneously formed. Modest growth down in this group. And the rest of those groups have largely been stable. There have not been a lot of major flares, although there was one kicking off as we did show prep. In fact, the largest flare of the past 24 hours occurred while we did show prep. No relativistic particles showing up. No major flares. Likelihood of major flares isn't all that high. The largest flare of the past 24 hours just happened. It was just below a C5. And the peak flux was right at 1100 universal time. And let's take a look at it from SDO 94 plus 131 angstroms wavelengths. Again, only minor flaring happening. Many of these sunspots are magnetically complex. We'll take a look at that at the end of the bonus features segment here before we do meteorology. About 2/3 of those sunspot groups are beta-gamma class. Next, looking at a star chart, this is what's going on over Lehigh Valley here at the moment. And we've zoomed in on Arcturus, the brightest star. And if you're up before dawn, you might see Mercury rising ahead of the sun if you've got a low horizon and clear skies and low light pollution, as Mercury is kind of dim. But there it is, just north of the ecliptic. Next, your solar system forecast. Here's where things are on the final day of January. You know, tomorrow's the first day of the rest of our lives. Here's your 1-week forecast. Here's where things will be on February 7th. Next, great imagery of a comet here showing up on stereo A. Now, I don't think comets are electric. I don't think the universe is electric. And if people are telling you the universe is electric and you're believing them, we recommend that the people telling you and you take Physics 2. Now, you can take all of MIT's courses online for free, including study materials, tests, lectures, and more. If you think the universe is electric, please take Physics 2, Electricity and Magnetism, so that you can learn what it means and why everything is not electric. If everything was electric, we would not need a term, electric. Anyway, there's some great imagery from George Mason University. Let's take a look at some more here from our Integrated Space Weather Analysis Center. We'll take a look at Stereo A from another data source. We'll also look at SOHO LASCO C3 at Lagrange 1. There's some more great images. And we see a bunch of CMEs there. And let's go back to George Mason for a brief moment here. This is yesterday's imagery. And yeah, none of those coronal mass ejections are earthly directed. They may look like halos. It's because we've got CMEs coming out of the north and out of the south at the same time. And that often makes it look like a halo when it is indeed not a halo. So that's the scenario. None of those coronal mass ejections are headed toward the Earth. But great imagery there of that comet. And comets are, I mean, they're not really space weather in my opinion. A lot of people think they cause coronal mass ejections and solar flares and things like that. And there's no evidence to back this up. If you've got some, please feel free to share it with the channel. We've got some additional imagery of that. There's the last 24 hours from SOHO LASCO C3. And we'll also zoom out. That does also include the SDO 304 angstroms wavelength. Again, those may look like Earth-directed coronal mass ejections, but not really. They're just simultaneously coming out of the polar regions there to the north and south, making it look like a halo, when indeed it is not. If there is any earthly directed ejecta in there, it's very diffuse and minor, and may not even show up with a signal. But as far as we can tell, no apparent Earth-directed coronal mass ejections. Next, looking at filaments. This is the ground-based solar observatory at Cerro Tololo, Chile, part of the National Sunspot Observatory. It's the same data source from which we look at the line-of-sight field plot, the coronal hole field plot, and the top view ecliptic plane field plot. So once again, we've got a lot of filaments. All these dark features are filaments. All of these prominences hanging out over the limb, those are all also filaments. So likelihood of additional coronal mass ejections remains at nearly 100%. I don't know if anybody named this filament yesterday or not, but we've got a few that we could name. So if you'd like to name a filament, pick a living person and name it after the living person on the Twitter feed. So we've created a hashtag just for this. Name that filament. You can't name the filament in the YouTube comments or the BitChute comments. You have to join us on Twitter. No censorship is not fixed. No free speech is not restored. Also, by the way, if you're looking for free samples, you can find a link to the Hemp Lucid free samples. We just put it up last night. You can get some free samples of mushroom gummies on the Twitter feed. So join us over there if you'd like some free gifts to try out some of the great products from Hemp Lucid, our latest affiliate/sponsor. Links to the Hemp Lucid shop below the video as well in the description. So here's the last 24 hours from SDO 304 angstroms. Great imagery there. The lively and normally behaving star, not looking like it's shutting down in any way. And here is the last couple of hours, about 2.5 hours there from the GOES 18 SUVI. We stream it regularly on the Twitch channel at twitch.tv/smashomash, and this brings us to bonus features. So let's check satellite charging hazards first. We've got some surface charging here over the Western Caribbean, Central America, Mexico, and moving into the Central Pacific Ocean there. Some surface charging hazards caused by low-energy electrons on the outsides of satellites. GOES electron flux here has dipped quite a bit just after midnight. That's midnight universal time. And it's a common theme with coronal hole high-speed streams. There's NOAA's forecast, the green box, expecting a little dip in the electron flux. It might get a little bit lower than that. Coronal hole streams are typically associated with low levels of electron flux. And there is the one-year graph to put it in context for you, just in a moderate portion of the range here. We'll also take a look at the F layer of the ionosphere, since we've been noting some oddities at about 300 kilometers of altitude. Here is the vibrational frequency. We'll also show the anomalogram. Interestingly enough, this is showing indications that the South Atlantic anomaly has returned to the South American continent. So that was almost as weird as it leaving the South Atlantic, because it went from the South Atlantic into South America, into the South Pacific, back up toward the equator, and then back to South America. So it went like this: over here, down here, up here, and then back down towards South America. If that's not weird, I don't know what is. And if you've got theories as to how Earth's geomagnetic fields are generated, please let us know in the comments. If huge structures of iron are required for the field to move, then how did the South Atlantic anomaly move thousands of miles in a period of only a couple of weeks? I find it strange. And here's the anomalogram. And you'll see right here, huge variations happening right over the South American continent, right where it used to be. So it has now snapped back into its original position. Is it an indication that the geomagnetic excursion is ending, or is it just continuing as it was? Of course, we would expect the South Atlantic anomaly to be more stable if the magnetic fields got more stable. And it just stopped playing there because reasons. So we've got quite a bit of anomalies here. You can see high and low frequency anomalies happening, especially around that area. That's anomaly in megahertz from a 30-day median. We show it every day on the channel. If you're wondering what happened on previous days, go check out our older videos. We show at least a day of it. There is the latest image, 11:45 Universal Time ionogram, and 11:45 Universal Time anomalogram. We'll also look at the total electron content forecast, which is the free electrons between your GPS satellite and your handset. That's a run of about 12,500 miles. And since those free electrons can cause signal refraction, the coupled thermosphere, ionosphere, plasmasphere electrodynamics model will show you the most likely places for GPS errors. So this is much more orderly than it was a month ago. It's even much more orderly than it was a week ago, although we do still see continued low electron content anomalies over the northern Caribbean and southern South America. We'll let it play through one more time. But looking much more normal than it had been. So most GPS errors are concentrated around the equator at noon. And we've also got the latest intensitygram and latest colorized magnetogram. Come on, you can load. There we go. Just great. So this sunspot up here, that is beta gamma class. This sunspot up here is alpha class. This sunspot down here is beta gamma class. This one down here is beta gamma class. And also that one there is beta gamma class. This is the most likely one to produce major flares in my opinion. May even be beta gamma delta class. Last but not least, this group up here, looking pretty weak. Hang on a minute. That is alpha class. We only see North Pole umbrae on that one. So the most likely place to see large flares, or flares period, would be from this region down here in the southeast. That's my word. That's my story, and I'm sticking to it, as I like facts. I'm not a fanatic about anything. But if I was going to be fanatical, it would be about facts. The truth is out there, and we prefer to bring it to our viewers instead of bringing them a bunch of nonsense. I know there's plenty of that on YouTube. There was a niche for space weather when we started the channel, so we filled it. Next, doing some wave hunting, and it's a bad day to go on Viking raids because there are 36-foot waves in between Iceland and Scotland. So if you're rowing a longboat, it might be quite a harrowing adventure to across the North Sea today. Is that the North Sea or the North Atlantic? I don't know. But anyway, where that green circle is, those are the biggest waves in the world at the moment. I think, let's just make sure here. Sometimes the Southern Ocean has some big ones. But nope. Sometimes the North Pacific has some big ones, but nope. Biggest waves in the world right there between Iceland and Scotland. Anyway, let's blast through meteorology here. We don't want the video to be too long. Surface winds of the eastern world are looking like this. Jet streams are as shown here. The entire northern portion of Australia is an anticyclone, an upper-level high-pressure system there rotating counterclockwise, as they do south of the equator. Here are the jet streams of the western world. Anticyclone here over southwestern South America. Concentrated jet stream over the eastern portion of the U.S. Here are the surface winds of this side of the planet. Surface winds of the central world looking like this. And jet streams as shown here. Continuing on, this is what clouds and fog are doing over the Americas. We're using the shortwave radiation satellite there at 3.9 nanometers infrared. Clouds and fog over the Americas. Next, our weather.gov map. If your location's lit, click your location. Lots of freeze warnings there and lots of winter storm warnings in central Texas. Again, if your location's lit, click your location. Looks like some great surf around Hawaii. Drop us a line if you've got any imagery of that. So that's your weather.gov map. Weather.gov, if your location's lit, get your alerts. And the story will be cold weather. So we're going to get a second blast here, especially Minnesota's going to get plastered with a second bout of cold air coming from central Canada. That is your temperature anomaly for the next 72 hours based on the GFS model in degrees Celsius. Next, your pressure and precipitation forecast. Lots of ice coming to Texas, Oklahoma, Arkansas, Tennessee, Alabama, Mississippi. Lots of ice in the southeastern U.S. Some significant ice accumulation expected. That's, again, your GFS 72-hour pressure and precipitation forecast. We'll also show the GFS total accumulated precipitation forecast for the same period of time, 72 hours. There is that data. Still expecting some significant snowfall in Mexico. Since some of that precipitation will be in the form of snow, expecting over 6 inches of snow there. Right down here in Mexico. Yowzers. That will be interesting. That's your 72-hour total accumulated positive snow depth change in inches. So that's the GFS model. Let's take a look at the Euro model real quick. There's the next 3 days, the Euro model. And here's the difference between the GFS and the Euro. The GFS model, they're forecasting more snow for Mexico than the European. But both are forecasting significant snow accumulation in that region. Dag. And let's continue on to close this mother out. So there is your NASA GOES lightning mapper data. A little bit of lightning in the U.S. there in the past about 12 hours. Do we have any terrestrial strikes at the moment? Certainly not. Eastern Mediterranean continues to see some lightning, though. Next time you hear thunder, maybe check out lightningmaps.org. Here's your Well, we're going to show the U.S. Doppler radar, but first take a moment to press like and subscribe if you enjoy the content. Check our playlists for stuff that has nothing to do with space weather or meteorology, like Do One Thing, driving, riding, and pro tips, ownage, food and drink, terms defined, cosmology segments, and much more, like product reviews. Smashomash.org presents The Sun. So hit us up on our playlists. You may find some interesting info there that you weren't even considering. Press like, subscribe, share, comment, tell your friends and foes about us. If you're an influencer, drop us a line. We'd be more than happy to appear on your channel. Visit our home site as well, smashomash.com, and welcome to the Neo-Renaissance. We are in the process of writing a paper that plausibly explains the solar sunspot cycles and the solar polar field reversal cycles. If you'd like to help us out, support us via the Smash Team or Patreon or even one-time donations. We need some new equipment to keep the videos coming, so help us out there. Yeah, we need a new PC and some hard drives and probably another monitor and some other things. So help the channel out. If you'd like to see the videos continue to exist, remain publicly visible, and free for all to view. Next, U.S. Doppler radar, we're looking at the youngest state in ALSA, the allegedly United States of America. There's Hawaii, and there is some precipitation showing up there and some weather warnings. Let's zoom out and show the largest state of ALSA, Alaska. A little bit of precipitation there. We're going to focus on the lower 48 and close this thing down. So there is your U.S. Doppler radar map. Looks like it's snowing in Texas. Here is our clouds and fog view, 3.9 nanometer radiation over Crescent Earth. And here is the water vapor. That should help clear things up. You've got two bands of dry, massive air there across the country, and some more moisture coming into the Pacific Northwest. Here's your recap. It's U.S. Doppler radar. Clouds and fog from the NASA GOES Interactive Weather Satellite Suite, and water vapor. And thanks for tuning in from Smash staff and I. We appreciate your pressing like, subscribe, share, etc. Tell your friends and foes about us, and we'll be back soon. In the meantime, may that solar wind be at your back. Facts stated in this video, suppressed by big tech organizations to improve your online experience. Opinions expressed in this video not necessarily the opinions of Smash News Network, least busted name in news.